So a continuation from yesterday. So today we're dealing with fractions mainly, right? That's all we're dealing with. But the rules are still the same. November, what is it today? Okay. So yesterday we did this. We did algebra. The key to solving any equation is to get the variable. That's not bad. All right, right? To get the variable by itself, right? You move stuff around, right? If something's positive, how do you get rid of it? Subtract it or negative it. If something you multiply it, how do you get rid of it? Divide. If you subtract it, how do you get rid of it? You add. If you do something to one side, you have to do it to the other side. Okay. Now let's just review fractions for a second. What could we take? We got 2/3. Our goal is to get rid of the denominator. Which one's the denominator? The top or the bottom? Bottom. Denominator, down. Down, 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 right? That's how you remember. What could I times this thing by? 2/3. It's a fraction, obviously. What could I multiply this by to get rid of the denominator? No, not just 1/3. I want a single number. 3. If I multiply this by 3, watch. If I multiply this by 3, now why am I putting it on the left and not the right? No. If I put it on the right, what does it look like? It looks like an exponent, doesn't it? If I put the 3 on the right here, wouldn't it look like an exponent? Okay. So I'm putting it on the left. Now watch. Couple ways to think about this. Here, let me do it. Let me do it 2 ways here. 2/3 and 3. Okay. 2 ways to think about this. What is 3 times 2? 6 over top of what number? No. 3. Okay. If you need to, what is this 3 over top of? A 1. Could you think of it that way? Yeah. 3 times 2, 1 times 3. Okay. 6 divided by 3, what happens to that? Does it reduce down to a nice number? No denominator at all? No. Okay. Now, another way to think about this.
I have to go get a camera and photography.
Could have done it after school. You had lots of time between classes to do that. Okay. Now, another way to think about this is, what's 3 over 3? No, 3 divided by 3. 3 over 3. Do they cancel each other out? Okay, watch. So another way to think about it is, yeah, those cancel out. What are you left with? 2. Do we end up with the same answer? Yeah. We end up with the same answer. So our goal, this is our goal, guys. Our goal. Eliminate the denominator. I'll get out of the way in a sec. Denominator. All we're doing is we're timesing it by 3. No, that's a different case. Here we're just taking a number and just multiplying it by 3. What's going to happen is, what we're going to do is we're going to get a left and a right-hand side of the equation, and what the point I'm trying to make is if you times this by 3, you're going to have to times this by 3, left and right. I'm just making a point. I just want you to make sure you understand what we're doing with the denominator. So let me give you an example of a fraction where this is going to, and you're right though, what you do is this left and right, top and bottom. We'll get to that. Yep?
It was like an honor team, decimal team, like fraction.
You could if you wanted to, but there's no sense in this case, right? Basically what you're trying to do, guys, let's just do an example, okay? Just let me throw an example up here. This will make way more sense once you see an example. Okay. So this looks like the stuff we did yesterday, right? But the only difference is we have a what in here? We have a fraction. It makes it a little more difficult to do, right? You'd have to treat it the same way, right? You'd try to get rid of the 1. You'd move the 1 to the other side by subtracting. Then you'd have to get rid of this 2/3. Just a little more awkward. Would it be easier if we got rid of the fraction? Yeah? Okay, now think about this. Yeah, okay, so that part is easy. You minus the 1 from the 5, but how do you get rid of the 2/3?
Well, then you just figure that out.
And tell me how you would figure that out. No. You have to divide by 2/3, and that's kind of annoying to divide by a fraction, isn't it? Because if you divide by a fraction, it's the same as multiplying by the reciprocal, right? Do you remember that stuff? A little bit awkward. Now what? I want to show you something. Look at the 2/3. Is there anything I could multiply that 2/3 by that would get rid of the denominator? 3. Okay. So here we go. I'm going to put brackets around this guy, and I'm going to multiply it by 3. And again, why am I putting it on the top left instead of the right? So it doesn't look like an exponent. Now, Liam, here's your thing. If I times this by 3,
Yeah, you said denominator, because last time you did the numerator. You said 3 times the denominator, right?
no, we're timesing the numerator here, but we're trying to get rid of the denominator. Now, here's the deal. If I times this by 3, what do I have to do to both these terms here? Times by 3. I got to take this guy, and I got to times it by 3. And I got to times it by 3.
You do that first or after you...
We do this right away because the goal is before we even start moving anything around, the goal is to get rid of the fraction.
That's here, denominator going on the other.
It is, but this time we have everything, so we're going to do everything. Basically what it is, it comes down to, guys, if I had a fraction that was a half, could you make me an equivalent fraction? Yeah.
Just get it clear, every time you're doing fraction, even without the equal sign,
Well, you're always going to have equal signs because we're going to be solving equations always. Could you make me an equivalent fraction with a half? What do you do? What is it? 5 over 10. How'd you do that? Times by 5, times by 5, right? Okay. So all we're doing is we're taking this equation and we're making an equivalent equation. So let's see what we get. 2 ways to think about this. You could look at it as 3 times 2, which is divided by 3, which is 2. Or could you just cancel the 3's out? Okay, if you cancel the 3's out, what are you left with? 2 what? X plus 3 equals 15. Okay, so what we've done is that 2/3 x plus 1 equals 5, and 2x plus 3 equals 15. What about those two equations? Do they look different? But guess what? They're exactly the same, right? If we plug in the x, they're exactly the same. All we've done is gotten rid of the fraction. Now, can we do this? Can we do the algebra of this? We know how to do the algebra of this. We spent all day yesterday doing it. Okay, what do we do first? What do you do? Subtract the 3 and subtract the 3. What happens to these two? They're gone. So we're left with 2x equals 12. Okay, now what do? I divide by 2 because the 2 and the x together are, when they're side by side, what does it mean? Multiplied, so we do the opposite, divide by 2, x equals 6. Okay. Let's see if we're right. Let's look at both equations here. Look here. Let's go back here. So we're going to plug in x. What's 2 times x? What's 2 times 6? 12 plus 3, 15. So it works for this one? Yeah? Let's check the first one to see if we're right. Careful here. 2/3 times 6. Uh-oh. What's 2 times 6? 12 divided by 3 is? 12 divided by 3 is? 4 plus 1 is 5. So does it work for either one? Okay, now, here's a question for you. Which one, in your opinion, would be easier to do? The first one or the second one? The second one. Why? Because but why? Yeah, but you know how to do this. You could follow the same rules, but what's the difference in the first one? There's a fraction there, right? It makes it more difficult. So if you can get rid of the fractions in one of these equations, you can do this. This is the same stuff the 10s and 11s do. It just gets more complicated. Okay, now here's a more complex one. See if you can do this one. You're not going to take notes, either of you, or what? Wow. Yeah, but so then you're going to sit there and talk instead while I'm doing this? You know what? Just be quiet, please. Like, again, just hang on a second. Still talking after I've told you not to. So now you're going to take out your compact and... Oh, that's interesting. Yeah, okay, whatever. Okay, well look. We want to get rid of the fractions, right? The fractions have to disappear. Now look at the first one. What can we times this first fraction by to get rid of it? A 2. Would that work? Yeah, the 2's would get it. But that would work for this one. We could times that by 2. But what about the next one? Can we times this one by 2? Oh, we got to times this one by 3. So we got to times this one by 2, and the last one by 3. Well, that doesn't make any sense because we have to be able to times it by the same number. What? 6? Would 6 work? What's that known as when we're dealing with fractions? We're finding a common denominator. And normally we like to find the lowest one, right? Would other ones work? Could you do 12 if you wanted to? 12 would work, right? 2 goes into 12 and 3 goes into 12. Would 24 work? Yeah, 2 goes into 24, 3 goes into 24. So those would all work, but we want to always find what? Which one? The lowest one. It's always the easiest. So lowest common denominator.
Get rid of it. 2. 3 doesn't go in 2.
I know, that's why we're using 6.
No, I don't feel like that.
Oh, so this one here, let's say you did it with a 2.
No, feel what's there. Like, how come we would do it by 2? This is just
Like this one here, if that one wasn't there, because what's the denominator? 2, so it will work.
always multiply by.
Whatever the denominator is of the fraction, and unless there's more than one, and then you have to find the LCD. So let's write this on the side here, LCD. What is our LCD in this case? What was it? 6. Oh, anything would work. 12 would work, 24 would work, 18 would work. There's lots of them that would work. Okay? So, we're going to take each piece, well, you try. Take each piece, this one, and this one, and times each of them by 6. Give it a shot. See if you can solve this. Your answer is going to come out as a fraction. Your answer is going to come out as an improper fraction. So if you've done it correctly, you should get an improper fraction, which means larger numerator, smaller denominator. Please do this. If you do the next line correctly, you should end up with no fractions as the next line. But your final answer will be a fraction once you're finally done. Did you end up with the... No, you did something wrong, then go back and try that one. So times everything by 6. So what's 18 divided by 2? What's 18 divided by 2? 9x. You should end up with no fractions when you're done. Right? Yeah. Okay, listen to what I said. The next line, you're going to have no fractions. And then you're going to have to still do the algebra, and when you're finally done, you will end up with an improper fraction. Yeah, because it's 24 over 1, right? Okay, let's do this. Come on, guys. There's 2 ways of thinking about this. You could look at, okay, guys, 2 goes into 6 how many times? 3. So 3 times 3 is 9, right? That's one way to think about it. Or the other way is, what is 6 times 3? 18 divided by 2, 9. Do you still get the same answer no matter how you look at it? Yeah, I don't care how you do it, right? So the first one is 9x, right? 6 times 3, 18 divided by 2. Or 2 goes into 6 3 times. 3 times 3 is 9. Doesn't matter to me. Minus, what's 6 times 4? 24. Okay, two ways of looking at it. 3 goes into 6 how many times? 2. 2 times 2 is 4. Or 6 times 2 is 12 divided by 3 is 4. Either way is fine with me. Some people look at it one way, some people look at it the other way. Equals 4. Okay, now, if you've done it correctly, like I said, do you end up with one single line? Now this is the algebra. So don't put scissors near your eyes. Just close your purse, please. Close your purse. Thank you. Leave it closed. Okay, what do you do now? To get rid of the negative 24, what do we do, guys? Add 24 to the left side. What do you do to the right side? Add 24. What happens to these 24s? They're gone. You end up with 9x equals 28. Okay, the key to solving any equation, guys, is to get the variable, in this case, x. The key to solving any equation is to get the variable by itself. What is x by itself? What's attached to it? A stupid 9. Yes, a stupid 9. Thank you. There's a 9 attached to it. How do we get rid of the 9? Divide. Both sides or one side? Both sides, both sides. Those are gone. X equals 28 over 9. Is that an improper fraction? Could you leave it as an improper fraction? By all means. Is it in lowest form? Yes, it is. So you're good. So what? What do you get? 3.11111. So what's more accurate? 28 over 9 or 3.11111111111? Well, no, obviously. Can you put 3.1111 into your calculator? No. Can you put 28 over 9 in your calculator? Yes. Guys, it's always better to leave it as a fraction more than a repeating decimal. Yep. But in this case, it is, because what are you going to put for your answer? But what would you put? What would you put as an answer? Tell me. 3.1111111111. Oh, the little bar. Oh, okay. So you want to put this 3.1 repeater. Yeah, you can, but how do you put that into your calculator? You can't. Could you put that into your calculator? Yes, you can. I know. The point I'm making here is, as you go through, guys, quiet please. As you're going through 10 and 11, it's all about accuracy in your answers, right? So you'll just leave it as a fraction. You'll get, most of your teachers will just say, leave it as a fraction, leave it as a fraction, leave it as a fraction. Always simplify your fractions, but leave it as a fraction. One last thing, guys. We won't do this one. But what if I gave you just, guys, we're not going to do this question. I want you to think about this for a sec. X plus 1 over 2 minus 1 over 6x equals 3 over 8. There we go. Don't do this. Write this down. Just so I want to see if you can get the point across on this one. There are a lot of fractions in this one. Every single term in here is a fraction, isn't it? Would this be kind of annoying to do? Could we get rid of the fraction? Yeah, you're right. I mean, that's why I'm teaching this. Now, here's the question for you. What number? 24. How'd you get it? Oh, so you just figured out what number they could all go into, right? The lowest, right? You could do this. If you ever got stuck, could you multiply all these together and use that number? 4 times 2 is 8, right? Times 8 is 64. What's 64 times 6? 384? Yep. Okay, would that number work? Well, I sure didn't use a calculator. Okay. Would that number work? Yeah. But it's not the lowest. Okay, so in this case, right? You could use, if you wanted to, 24. Would that work in this case? Yeah, it would, right? 4 goes into 24, 2 goes into 24, 6 goes into 24, 8 goes into 24. It will work. Would that make it a heck of a lot easier? Oh yeah, because it would get rid of all the fractions. That's what you're going to do in this one. Okay, so what you have to do now, guys, from yesterday's lesson and today, you're going to do a whole stack of algebra questions, including fractions. Okay? Get about it. Get at it. Get at it. Just do it anyway.